Yeah, I greet you wherever you are watching this video. This is a question that talk about the Lindemann mechanism for unimolecular. Is as follow. This is the mechanism given to you, and the question states: apply steady state approximation to derive the rate law using the mechanism given to you. That means this mechanism, okay? And you are going to be using steady state to derive the rate law. So simply, if whether they say use steady state or not, what you are looking for is the rate law, okay, using this mechanism. Okay, so I want to say here that is how the question came, but I want to say here, first of all, let us look for the overall reaction. Okay, for me and my overall reaction will be what? A plus A, adding everything together, plus my A star to give me A star plus A plus Y plus Z. Do you get it? This will go. Then I will be, one A will also go. I will be having A to give me what? Y plus Z. Actually, this will be my overall reaction. Okay, this will be my overall reaction. And now let's go to question number one. Apply steady state approximation to derive the rate law. Okay, I will take the first one by taking my rate law for each of the elementary step. So I will say my R1 will give me what? K1 A, then A. You get it? Then R minus 1 will give me what now? It will give me K minus 1, then A star, then A. Do you get me? Then I will take the third one, R2, which will be what now? K2, A star, okay? That will be, so I call this equation 1, this equation 2, this equation 3. Do you get me? So the next thing is that I will be applying my steady state. Often, please, first of before we go there, just know that my intermediate, yeah, my intermediate is what? My A star, because it's produced as A star and later consumed as A star. So that is my A star. That is the activated A. Okay, so that is my intermediate. So if I am going forward, I will be saying, applying my steady state, I will say let R1 is equal to R minus 1. When I do that, I will be having, what is my R1? K1 concentration of A is equal to uh, um, R minus 1, which will be K minus 1, A star, then A. Please, this is not minus 1, okay? For easy talk, I need to use it is a subscript. Do you understand? Just as you have did. So this A will cancel this A. Okay. Remember, I'm looking for A star. So my A star, my activated A will now be what? K1 over K minus 1, remaining what now? A. Okay. So what is the next thing? My rate determining step, RDS, which is my rate determining step, okay, is this. This is my rate determining step, which is this, okay, A star to give me Y plus Z. So what is my rate determining equation? My rate determining equation will give me what? K A star. Do you get me there? Okay, that is my rate determining equation. So if I call this equation 4 and I call this equation 5, you can see that my intermediate is already this. So I can put this intermediate into 5. Where is my rate determining equation? So I will be saying that put 4 into 5. That means I will have my rate, uh, that is my equation 5R will be equal to what now? K, or I obtain it from here, is the same thing. Please understand, is the same thing. Okay, I can use this. Okay, if I am using this, I'll be saying K my A star is what? K1 over K minus 1, then A. That means I'll be having, if everything here turns to K, and I have R is equal to K A. If I use this, is the same thing. This is my answer. That is the rate law. Okay. If I use this, I'll be getting the same thing, that R2 is equal to K2 star. Okay, that means that is my equation T. In that case, I am putting 4 into 3. Do you understand? Because 4 is my intermediate, and my 3 is the rate determining equation that contains the intermediate. Understand that the rate determining equation, or the rate determining step, always contain your intermediate, and so you will substitute your intermediate into the rate determining step so that you can obtain your rate law. So if I'm doing that here, I will be saying put I'm putting 4 into 3. So put 4 into 3. I'll bring up my 3. R2 is equal to K2. Then my A star is what? K1 over K minus 1. Then I have what? A. So if I say let R2 is equal to R, and K2 K1 over K minus 1 equal to K, I will be having what now? That my R, okay, R is equal to what? K A. Do you get it? That is my answer. Okay, so, and then the second question says that show that the reaction is a first order at high pressure. So that is the answer, that at high pressure, it shows that it is a first order reaction. Okay, because the order of reaction is the power to which, is it at high pressure of A, is the power to which the concentration of A is raised up. Okay, so it is raised to the power of 1. So since order of reaction, okay, is equal to 1, therefore it is a first order. And they say show that it is a second order at low pressure. Okay, you can put it like this, that at low pressure, okay, if you want it to become a second order, that means you shall be having this. Okay, R is equal to K A raised to the power of 2, or you just put another A simply, which will be R is equal to K A, okay, raised to the power of 2, to show that it is a second order. Thank you for understanding this, and I will advise you to just share the video, and also subscribe, put on the notification button. Whenever I upload a new video, you will be notified, and then watch. Thank you. I remain your tutor, Akpeji Honesty. Before I stop this video, understand that my rate determining step is this. Do not forget. Okay, and my rate equation is my rate determining step is this, and my overall reaction is this. And so you can see that the rate determining step has the product y plus z, and my overall reaction has the product y plus z. I believe you do understand. Thank you very much, and God bless.